Section 3 is concerning the future value formula, which we have here on our formula sheet. In fact, there are two versions. For the first three problems, we're going to be using the second future value formula, the one that has the I's and the N's. So number one, we're looking for the future value. We have payment, that's $77 in hours, times, now this fraction goes right beside the 77, the interest rate is 0.04, so that's 1 plus 0.04. The N is 29, now there's a minus 1 in the formula, and then the 0.04 again. We'll take out our TI calculator and enter this using our TI-84. Now to do this with the TI-84, we'll do 77 times, then we'll go to the green alpha key, the y equals key, choose number 1, which is our fraction template, and then enter the fraction. Rounding that to 2 decimal places, which would be 40.78 and 40 cents. So in the second one, we're told that the future value is 37.70, so we'll start with the 37.70. And then the payment is what we're looking for. So we'll just use PMT in that spot and then finish out the formula. And use our calculator on that. Now we'll be typing on our calculator this portion, getting the number, and then using that to finish out the problem, but not re-entering that. Again, we will write this down, but we won't be entering the rounded off version, or we will miss the problem. And to finish the problem, we need to divide by this 17.89. Calculator, we will do 37.70 divided by, and again we do not want to type 17.89, we want that entire number, which we get by doing second ANS, and there's our final answer, and we can round that to 2 decimal places. Same formula. The future value on this one is the 9,000. We're told the payment is 200, and the interest rate is 0.03. We're solving for the N, going to do this by hand, and so we want to begin by dividing both sides by 200. That's going to disappear. And these two zeros and these two zeros will disappear, and we'll have 90 divided by 2. I can do that one in my head. Next, we want to multiply both sides by 0.03. That will disappear. And 45 times 0.03 is 1.35. We need to add 1. Now we change from exponential form into logarithm form. The base is the 1.03. The logarithm is the exponent, and then the other number, 2.35. Now we'll type this on our calculator using the alpha window number 5 and entering our base and the other number. Again, we don't want to round off yet until we see what the instructions are. 28.9, etc. And it says round up to the nearest integer. So that is actually the proper way we would want to round anyway with the 28.9. So that's going to be 29. Now we know we're using the future value formula, but let me remind you that here we're told that $1,808 is deposited every month. That's telling us we have an annuity, and they want to know how much will be in the account at the end of 9 years. So that tells us we're looking for the future value. Now we're going to use the other version of the future value formula, which again is on the formula sheet. So we're looking for FV. The payment is the 1808. This is 1 plus R divided by M. R is the interest rate, 0.051. M is the method of compounding, which is monthly. That's 12. The exponent is the time T, which is 9 years, times the method of compounding, TM, which is 12. So, typing this into our calculator is the trick. I will type that and let you see what it looks like without having to wait for me to type each key. We want to round this to the nearest dollar, which would be 247,144. Now, to find out how much is interest, we need to take the amount we deposited each time, which is 1808, and multiply that by the number of deposits. We deposited that monthly, which is 12 times a year, for 9 years. Now I'll just enter this into my calculator without think you can handle that on your own. And the interest is the difference in how much we have at the end of 9 years and how much we actually deposited. So all we do is subtract those two. On number 5, we're using the same formula, only this time we're looking for the monthly payments. So we have a future value of 144,000. PMT is what we're looking for. And 1 plus 5.4%, 054, compounded monthly for 20 years monthly. Now, I don't know, I've done this a couple of times, so I won't make you watch all of it. I'll pause my video and enter that and show you what it looks like on my calculator. But we did this in a previous problem, or something very similar to it. We're going to be entering this into our calculator, using that number to figure out the payment, without retyping that number or rounding it off. Now, this number to the nearest cent would be 334.44. In the last problem, we're looking for the length of time, and we'll be using the same formula. So we're going to take our future value formula, fill in the quantities. The future value is the 10,900. The payment is 100. The interest rate is 3.9, or 039. It's compounded monthly, and we want to know how many months. Now, if we just use the n here, it will come out to be the number of months. If we use t, it will come out to be years. And of course, we would have to have t times 12 there, and then we'd have to convert that back into months anyway. So we'll just use the n for months. Now, just like we did in the previous one, we're going to solve this one by hand. And in a later video, if you want to watch the video for section 4, I do solve those using the graphing calculator. I would have shown you that in class. However, I'll do this one by hand. So here's what we will do. We'll divide through by the 100. This would come out to be 109. We'll multiply both sides by the 0.039 over 12. That will disappear. So then we need to add 1 to both sides in order to get this by itself. Now, we're going to be converting this to logarithms, so we'll go ahead and do these calculations and store them using the store feature of our calculator. And I'll show you how to do that. We're going to be entering this into our calculator. storing that in some letter. We'll just use the A on our keypad. We're going to do the calculation here and store that. So using our calculator, we've got 1 plus 0.039 divided by 12, which we will store in letter B. So we have converted our formula into this. We have an A and B and N. We convert that into logarithm form. That would be base B. Logarithm is exponent, and that must be the A. We'll type that into our calculator. And round off appropriately. Now again, pay attention to instructions on rounding. It does not say round off. It says round to the next higher month. That would be a 94.